Welcome back. In this tutorial we're going to cover Advanced Ortho number 10. This one looks a little daunting, a lot of hidden line work in there. In reality it's not that difficult. So let's go ahead and ask our questions. Does it have symmetry? And the answer is no. However, if this section was not removed, it would have front to back symmetry. So we're going to go ahead on the assumption that we're going to start it off symmetric and then just kind of let it lie where it does when we're done with it. So how would we describe this shape? I would say that it's kind of got a rounded off corner on this side. I'm going to fill it down on the bottom. This is kind of a tough one to describe. Which view best shows the shape? I would say the front view, looking at it in this direction. So that's where we're going to start. We're going to start sketching on the front view. And we're actually going to start with this circle here. Pay close attention when you're working on this. This arrowhead points to this circle. This is a radius. From here to here is 0.81. If you double 0.81, it's 1.62. So pay attention to that when you're working on this project. So we're going to pop over to Inventor, start a sketch on the front. I'm not going to bother to project any geometry, and I'm going to draw a 1.62 circle. Now we're going to do this one kind of similarly to the other ones that we've done. I'm just going to get a shape in here. That's all I'm going to do. I'm going to come down. I'm going to come over. I'm going to come up to the quadrant of my circle and close it off. Now that last line is not very good. So if we put a tangent constraint between these two, that should snap that in. And the way to tell if that's true is to trim this arc here. We need a horizontal constraint on this line. We can see it's kind of jagged here. And so that looks good. And let's start putting in some dimensions. So I've got 1.19 and 1.94. So let's put those in. 1.19, 1.94. And it's looking kind of squatty, which is okay because we know we're going to have to shorten it up. So this is 4.12 from the center of the circle to the far right edge. Now this is chamfered, but we've got some construction lines to kind of help with the corners. So you're not going to see any of this line work in here. So 4.12, and we're going to drag this back. Now notice that it lost this tangency. So let's go ahead and add a tangent constraint between those two. And this is 1.62, so we'll go ahead and add that in. And what else do we need? Well, we know the angle of this is 30 degrees from vertical. So from horizontal, it's going to be 30 plus 90, which is 120. And it says we need two dimensions, so we know we need that dimension there, and that dimension we're going to have to figure out. So from this center of this circle, let's back up a step. From this corner to the right edge of the part, we don't have a dimension from here to here. Not explicit. We do not have any dimension from here to here. So the best way to figure it out is to look at this location here, because we know that from the center of this circle to this corner is 0.75. And that we know from here all the way back to the right edge of the part is 1.88 plus 0.75. So if we take 1.88 plus 0.75 minus 0.75, the resulting distance from here to here has to be 1.88. So if we throw in a dimension from this point to this point of 1.88, we're good. And it says we need one more constraint, but I don't see where it is. So just going to kind of drag some of my geometry around here a little bit to see if I can figure out where it's telling me that I need an additional constraint. And I'm not seeing it. Trying to grab lines, trying to grab endpoints. And I don't see it, which I believe I'm fully constrained. So we're just going to go ahead and roll with it. So the overall depth of our part is 1.5. So extrude this to a depth of 1.5, symmetric. And I'll show you why that's important in a second. So let's back up and let's take a look at what else we need to do. I need a hole here. I need a hole here. I need a hole here. I need some chamfers. I need a notch. So let's do our chamfers. And it says our chamfers are 0.25 by 45 degrees. So if I chamfer distance, 0.25, this edge, and this edge, the result chamfers off all of this under here, which I don't want. What's the point of me showing you this? It's that order matters. So we can't chamfer yet. Okay? Can I put a hole in this face concentric to this, no seat with a diameter of 0.625? And how we know that is it says 2 holes here. Since these 2 are the only straight holes that we have without a seat, like this counterbore, I know that 0.625 also applies to this. So let's change our diameter to 0.625 and hit OK. Now, I'm going to start a sketch, and I'm going to project geometry, all 3 planes, and I'm going to throw a point down that is 0.75 from the edge. It's in the middle, which is why I wanted to make this extrusion symmetric, part of the reason. Now I'm going to put a hole in, and I'm just going to hit OK because it saved all of my values from my last hole. I can put the counterbore in, this face, this reference, and that was 0.75. And this reference is also 0.75. Now we know that's a counterbore, so we can check our dimensions. So I've got a 3/4 inch counterbore with a 1/2 inch through that's 0.5 deep. So this dimension needs to change to 0.5. This dimension also needs to change to 0.5. So 0.5 there, 0.5 there, and we hit OK, and there is our counterbore. What else do we need to do? Well, we need to make a cut over here. So let's take a look at that cut. What do we know? Well, we know that from the center point to the edge of that cut is 0.75. And we know that we're taking all this material out 0.75 inches back to here from the front. Let me reword that, sorry. From the front of this to the front of this is 0.75 because this whole part is 1.5 and we've got 0.75 here. Hopefully that made sense. So where do I sketch this cut and what shape do I make it? Well, I can sketch that cut on the front face. I can put a center point rectangle and dimension from here to the center at 0.75. Now, this isn't going to work because it's not coming over far enough. So let's go ahead and undo that and throw in a 2-point rectangle. Same concept, except this dimension comes here, just like before. Now, since it's not symmetric, this side is movable. It's not constrained. Do I care that it's not constrained? No, I don't. This right here is the only number that I care about. When I finish sketch, I'm going to extrude this as a cut 0.75, and I'm done. Now, another way to do that, and it doesn't matter, is to sketch on top. And I can rotate, I can rotate my view. And I can do the same thing. I can put in a rectangle after I project geometry from here over to here. The distance between these two, 0.75. And now I can extrude this as a cut through all, and I get the same result. So it's kind of a 6 of one, half dozen of another kind of concept. Whichever works for you is fine by me. Now I can put my chamfers in. So let's get those knocked out. And looking at it, there's two things I need to do. I need to put this little notch in, and I need to put a fillet down here. Order is important, and I'm going to show you the way not to do it. So what do I know about this notch? I know it's 0.19 tall, and it's 0.5 deep, and it's symmetric. So let's go ahead and sketch on this plane. Project our geometry, because we have symmetry with our feature. I'm going to put a 2-point center rectangle on. And I'm going to say this is 0.5, and this is 0.19 what? Times 2. And that's going to give me a height here of 0.19, which is what I'm really looking for. Now I could have drawn a regular rectangle and put a couple more dimensions and constraints on there, but this is a pretty good way to do it, so we're going to roll with it. So I'm going to extrude all 4 of my faces as a cut through all. Now we can see where it cuts through this face back here. It also cuts through my hole, which if we look at this shaded with hidden edges isometrically, we see that, that's interesting. Let's look at it wireframe with hidden edges. We see that we've got this kind of bulge right here, and when we look back, we see the same thing on our example part, so that's good. So back to why order is important. Order is important because when I go to fillet this, it should not look right. And it doesn't look right. This fillet needs to come down all the way to here. And so what I needed to do was put the fillet in first and then the notch. And the reason I wanted to show you guys this is as we get into more complicated parts, you're going to kind of have to work through these different scenarios, right? Especially when you're working stuff on your own. So let's take end of part. Let's drag it up so that extrusion 4, our notch, doesn't exist. Let's try that fillet again. And now it looks great. So if I drag end of part down, we're good to go. So I didn't have to delete this. I just had to reorder some stuff. Not a big deal. Typically, I like to do chamfers and fillets last, but that's not always able to be the case. So that's going to conclude this advanced ortho. Thanks, and we'll see you in the next one.